Okay, I'm gonna call your name. If you could just kind of raise your hand, I'll come give these to you. Melanie. Okay. Lewis. Daza. Where's Daza? There you are. Lewis. Dominic. Yamna. Where's Yamna? Let's see. Marcus. Jordan. Ashley. Stephen. Juan. There you are. Elijah. Alan. Okay. Brandon. Let's see. Emily. Hello. Come on in. Emily. Crystal. Farah. Where's Farah? There you go. Matthew. Where are you going? Sit. Sitlali? Am I saying that right? Did I say that right? Really? That's a first time ever. Amanda? Sophia? Isaiah? Sana? Oh, I messed up. Okay, I'm sorry. I'm sorry. I do it all the time.
Okay.
I just read. I don't even pay attention. Were you happy with it, or? I think you did. Yeah, no, you did good. Hector. Hector. Gabriella. Jacob. Let's see. Yamna. Who am I missing? Missing anybody? All right, let's talk about this test. So first things first, the way that I grade tests, a few things. First thing, if there's 12 problems, right, there are 12 problems, I grade each problem on a 10-point scale. So the maximum you could have got was 120 points. So if you missed nothing, then you received 120 divided by 120, that's 100, right? If I took 60 points off, then you would get 60 out of 60 out of 120, which would be a 50. So if you're trying to figure out like why I took off 8 points, but it's not a 92, does that make sense to you? It's just a ratio, all right? That's first thing. Second thing, when I grade your test, what I do is I put them all in a stack, and I grade everybody's number 1, and then I flip, okay? So if you were the first person graded, you're gonna now be the last person graded on page 2. And so I grade everyone's page 2, and I grade everyone's page 3. And so as I'm grading, other than the first page, as I'm grading, I don't know whose test I'm grading, right? I'm just kind of grading. And to me, that's the best way to do it because I don't know whose test I'm looking at, and there's consistency and fairness, all right? That's the way that I do it. What was your name? Sophia? Sophia, right? Okay. So the grades were really interesting. I don't have this happen very often. So some of you may have heard of this before, the standard normal bell curve. You heard of that before? All the standard normal bell curve says is that if you have like a large enough population and you take some measurement, you know, let it be like I don't know, height or weight or something like that, that you have this standard normal bell curve. You have people that are going to, there's going to be a lot of people, this is your average, X bar, that's your average. There will be a lot of people near the average. There will be some people that are far away, you know, and some people that are, you know, below and above, right? That's a standard normal bell curve. I don't see this very often in math classes. What I normally see in math classes is something like this. It's actually an inverted bell curve, where I normally see students that, like let's say this is 100 and that's 0. I get a lot of students that do really well. I get a lot of students that don't do well. This is just what I see historically, all right? What we have here, and I was kidding with my daughter, it looks like y'all are giving me the finger, right? Like, yeah. right? That's kind of what that looks like. It's a weird distribution because what we have is something like this, where we have, I would say it's more like the standard normal bell curve, right? It's more like this than it is this. We have a lot of students in the average, and we have quite a few here and quite a few here. See, it doesn't taper off like the bell curve does. That makes sense, Jill? So it's weird. I can't remember ever seeing this before in a class, so it's an interesting kind of situation we're in. The good news is that we have a lot of people near the average, which is, you know, isn't that what average means? Like a C in college, a C means average, right? B is above, oh sorry, wrong way. B is above average, right? A is supposed to be exceptional, right? And then D below average, F way below average, right? That's the way it's supposed to, I mean, that's the meaning of the grade, right? So to have a lot of students at the average is actually what you should see. Now, these are the actual grades for the 25 students who took the test. These are the actual grades. Of course, you can't tell who's who, right? But our average for the test was a 70.7. The standard deviation is a measurement of how far apart those grades are spread out. And so that standard deviation is pretty normal for me to see. So I don't know, it's kind of weird. Not sure where we're gonna go from here. I mean, we'll see how the next test goes, right? I'm not alarmed by this or anything, but I would like to see more people move this way. So for this test, what I'm gonna do, and do not expect this because I don't normally do this, all right? I'm gonna allow you to do corrections, all right? If you do corrections, what you have to do is on a separate sheet of paper, you're gonna go through each problem that I took points off, and you're gonna make the correction, and you're gonna explain at the end in words, in a sentence, using proper periods and not like you're texting me or something, right? Like proper sentence, explain the mistake you made and how you've rectified that mistake. That makes sense? And you do that for each problem. Now, there's a catch to it. The most you're gonna get back is 5 points, no matter if you missed, if you're down here, you're only getting 5 points back. That's it. If you're up here, you're only getting 5 points back, all right? That's the deal. It's not gonna be like a weighted curve to the grade. So that, in theory, if everyone did that, then the class average would go up by 5 points, and so the class average would be right in the middle of a C, all right? You don't have to do it. You can if you want, all right? That would be due, let's make that due a week from today. All right, so next Tuesday. And then when you turn it in, you're gonna turn in the exam and then a separate paper with your corrections. Do not do your corrections on the exam, because what I wanna do is look at them side by side, all right? Any questions on that? Any questions on anything else on the test? If you have any questions on anything specifically, like why I took off, I think that's something that we can reserve for either after class or you come visit me during my office hours and I'll show you, oh, right there, I took off. If you have any argument that you want to plead your case as to, hey, I don't think that you should have taken off that many points, then you can plead your case, all right? Sometimes I change my grade a little bit, say, yeah, I was a little harsh there. I won't ever say, you know what, I forgot, I missed that one. Let me take off. I'm not going to do that, all right? Your question.
Is there any way to go over how to do the trig function?
I can go over that after the corrections are turned in.
Okay, awesome.
Yeah. I would like for everyone to go kind of revisit that themselves. Anything? Did you raise your hand? No? Okay. Any other comments or anything? All right. I hope that you felt like it was a fair test. I hope that when you looked at it, you weren't like, oh, this seems completely crazy. I've never seen this. I know they were what, was it number 3? Number 3, I kind of threw at you. That wasn't on any review, right? But that was more, do you understand the different types of discontinuities you can have? And then other than that, I tried to follow as much as I could what I've given in the past. So you didn't get a test. What's your last name? Who else needs theirs? Just come up and grab them if you need them. They're right here. I think that's you right there. Right there. Okay, so if you did well, good for you, right? We still have a long way to go, so don't get complacent. If you didn't do well, it's just the first test, right? There's time, but you're going to have to make some adjustments. I know a lot of you have, it's the test anxiety that you get in here and you blank out, right? You're like, oh my gosh, you freak out, and I don't know, I don't have a magic pill for that, I'm sorry, I wish I did, but it's just one of those things in college you have to kind of find a way through. I remember I took a math class, what was it? I think it was complex variables was the name of the class, and we had a midterm and final, and that was it. 50% for each test. And it was like, whoa, talk about stress. You go in there and half your grade is just one test. So, yeah, it's the way it is. Okay, we're moving on. All right, so kind of recap, because I realize we have had a test, and so maybe you've forgotten where we were. We had talked about the derivative, right? And we had come up with two definitions for the derivative, right? I'm going to put those on the board over here, just as a reminder. We have this thing called the derivative of some function f at some point a. And the first definition of this is the limit. The first one we learned was limit x approaches a, f of x minus f of a over x minus a. And that's what most of you all used on the test for the last two problems. A lot of y'all used that formula. And then the other formula we have, the second version of this, was a different picture I drew for you. Limit h goes to 0, f of a plus h minus f of a all over h, right? Those are our two definitions. They mean the exact same thing, right? They both give you, both of these are equal to what we would write as f prime of a, like that. Okay, that's where we are, right? We also talked about how if you're given position, a position function, that the derivative gives you velocity, and that the derivative of that velocity function gives you acceleration, right? That's what we covered in 2.1. Now we move to 2.2, where we're going to be looking at the derivative as a function. Now, this is very visual, all right? And I will kind of warn you that this is like one of those light bulb things. You know when you're trying to understand a concept and it's just like you just suddenly get it? That's what this is going to be. Until you get it, it's going to look weird. Once you get it, it's going to be pretty trivial to you. But it's that making that going across that bridge, all right? So we're going to do that today, and if we have time, we will get into 2.3. I believe on our schedule we are 1 day behind. Yeah, we're 1 day behind. So we took our exam, right? And today we're supposed to be starting 2.3. We're actually starting 2.2. So we're a little bit behind. That's okay. I mean, we're still fine here. All right, so we're going to now talk about the derivative as a function. The derivative as a function. So I'm going to go back to our drawing. And I'm going to draw for you again this picture right here where we got that second definition of the derivative from. Okay, so when we were doing our picture, we had some graph of some function f. I picked some point over here, a, right? And then I picked another point to the right of it, which I called a plus h. It's whatever that number is plus something. And then I got that point. And then we connected these 2 points with a line. And then we said the slope of that line, the slope of the line would be the rise over run. And the way we got the rise over run is we did this point right here is the point A, f of A, right? A is the x-coordinate. What you get when you plug into the A into the function is the y-coordinate. And then this point is A plus H, f of A plus H. So that should all look familiar to you because we've talked about this. So we do now the slope. So rise over run is the difference of the y-coordinates over the difference of the x-coordinates. So take A plus H, take away A. And what happened on the bottom is that the A's went away and we just have H on the bottom. And that's this formula, almost, right? Because what we need to do is we need to move this point and slide it over, don't we? And to slide that point over, that's where we let H go to 0. So we put the limit in front and it moves the 2 points on top of each other, essentially. Right? We all comfortable with that idea? Now, when I used this letter A, could I have used a different letter? Could I have used B? Sure. C? Right? Any letter I wanted, I could have used here, right? And do you remember that last class when we were doing this before the test, when we did these examples, what we were doing is instead of actually having a value for A, we were trying to get a general like master formula, right? We would do this and try and get some master formula for the derivative, and then we could reuse that formula over and over and over. Well, that formula that we would get had A in it, right? It would have A in the expression. If I change this to a B, then do you agree that that formula we would get would have a B in it, right? If I change that to a C, it would have a C in it. So we'd have this formula. What we're going to do today is we're going to change this A to X. And then that new formula is going to have what in it? X. And if we have this new formula with X in it, we can almost look at that as a brand new function. Right? It's a brand new function. And so that's what this section is about. It's looking at the derivative, that computation, we're going to start to look at it as a new function. So let's change it. If I change this to X, and that 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 to X, right? The X's would go away here, right? Then our new formula would look like this. Instead of writing f prime of A, I would write f prime of X, right, instead of this. And then that would be the limit as H goes to 0 of f of X plus H, right, that's this now, minus f of X all over H. And this is the derivative of f at x. But the big takeaway today, like I said, this is a new function. I think 4 exclamation points is sufficient. So let's do one example. Algebraically, if you just give me your tester here, Marcus. All right. Okay. Let's do one example algebraically and just see that it's the same thing we've been doing, all right, but just no A, we're going to have X instead. And then we're going to start to try and visualize what this new function looks like. And there's going to be a really, really cool connection between the original function and the derivative function. You can look at the two and see how to get one from the other. And that's the part I was saying is like a light bulb that's going to need to go off. All right, so let's start with the function. And I have an example ready to go here, so let me look at it real quick. 3. No. Maybe not that one to start. Let's do something a little easier. All right, if f of x is equal to, let's go with 3x squared minus 5x, I want us to find f prime of x. So I have a function, right? This is a quadratic function from college algebra. And I'd like for us to take a look at this thing that we call the derivative of that function at x. This right here gives us this new formula, right, with x in it, that somehow tells us about the slope of the tangent line on this function, right, at different points. So let's just do the actual arithmetic. I erased the formula. Let's put my new formula. Today's new formula is limit h goes to 0, f of x plus h minus f of x all over h, right? That's our new formula for today. This is the definition of f prime of x. So let me write that down over here. F prime of x will be equal to the limit as h goes to 0. All right, let's see if we can do this together. The first thing I'm going to do, top left corner of this formula, is I need to plug x plus h into the function, right? Into this function, I'm going to replace all the x's with x plus h's. So let me write that down. 3. I have an x plus h that needs to be squared, minus the 5, and then the x plus h. So this right here, everything you see here, is the top left corner, f of x plus h. Do I have any questions on that? I mean, we've done this before, but I just want to make sure everyone's clear on what that is. Everyone's good? Okay, next step. I need to figure out this top right piece, f of x, and I need to subtract it, don't I? So I'm going to put minus, and then I'm subtracting f of x, but that's f of x, right? So I'm going to subtract that whole thing. So I'm going to write down 3x squared minus 5x. Is that correct? It has to be this has to be in parentheses. Why? Well, because we want to subtract the entire function, right? And if you just put a minus here without parentheses, you're only subtracting the first term. You're not subtracting the second term as well. So that minus must distribute, which means this needs to be in parentheses. Clear? Okay, all of that. And the good news at the bottom is always h. Okay, so there's nothing to do there. All right. Now, if we were to actually do this limit right now, if we were to do it, if we were to let h go to 0 right now, I promise you, just like before, last class, we would get 0 over 0. Okay, so we need to do some algebra right now to make this thing clean up, and our ultimate goal will be to try and get that h to go away. All right, so let's do the algebra. Limit h goes to 0. Okay, I'm going to do this piece right here, right? I'm going to do that one just real quickly up here. I have a 3, and then I have to FOIL x plus h times itself. And that's going to be a 3 times, and when I FOIL these together, I get x squared plus 2xh plus h squared. I'm not showing all the work for that, but we've done it a few times in this class. So that's this thing FOILed out and collect like terms, and then distribute a 3 through to all of those. So my top left should be 3x squared plus 6xh plus 3h squared. We good? Are you sure? We're good? That's just this, right? That's just this. What do we still have? This here, right? So distribute your negative 5 through to both of those. You get negative 5x minus 5h. So just to color code this thing, all of this here were those two pieces right there, right? Then I have to do this part, right? So I'm going to subtract this, so I'm going to distribute the negative through now. So I get negative 3x squared plus 5x. That right there is this together. And then everything I see here over h. Good? Good things should happen, all right? If you do all the algebra right, good things should happen, and we should eventually be able to cancel this h out. Do y'all see this? 3x squared minus 3x squared, gone. What else cancels? 5x's cancel. right? And nothing else goes away, right? Everything else is still there. I'm going to work above this here. So I'm going to rewrite this. See, I'm still writing the limit. Some of y'all lost points on the test for like just dropping the limit. Still have a limit, right? I have not let h go to 0 yet. So all I did was wrote the 3 pieces that were here, right? I just put those in my numerator. And now, what am I going to do? Factor an h out of the top, right? All of these have h's in them. So I'm going to factor GCF, right, back in college algebra. Do a GCF out of the top. H comes out. I got 6x there, plus 3h, and then minus 5. And all of that over h. And that now allows me to cancel or reduce that h. The math faculty had a meeting the other day, and we were talking about that. You know, the h is going away there. We were talking about something else, but a lot of students will say we're canceling the h's, and I say that too, but technically it's called reducing. You're reducing the fraction. Nothing is canceling. It's just like if you take the number 4 over 4, that's 1, right? You're reducing this to something else. You're not canceling things. So I don't care personally. Say cancel, but some math faculty were like, don't say cancel. It's not right, and so whatever. So if you take another class and you hear someone who's telling you don't say cancel, I told you, right? It's a personal preference thing. All right, what now? Do we have a problem anymore? I mean, do we have any division by 0? Is this a limit we can actually take? Right? Can you just look at that and let h go to 0 now? Yeah, you're not going to get 0 over 0 anymore, are you? So if h goes to 0, right, now we're about to let h go to 0. This becomes 3 times 0, so this will go away and become a 0, right? But everything else is still there. I still have a 6x, right, and I still have a minus 5. And that is my answer. Do you all see now that this is a new function, right? We started with a quadratic function, and we found this new function, which we call the derivative of that function. And that derivative is this function right here, which happens to be what type of function? If I were to ask you to graph that, what would that be? A linear function. Good. So I'm going to put this up here. We just found that the derivative of this function is equal to 6x minus 5. All right, so there's a big concept here that I want you to really see if you can wrap your head around. What we're doing here is we're taking a function, right? And we're doing something to that function and creating a new function, its derivative, right? This operation of taking the derivative takes a function, does something to it, creates a new function. That's this process. This limit does that for us, right? It's kind of like, think about this. If you have, let's say you have a function. Let me give you a function. F of x equals x squared. You probably remember seeing this in college algebra, something like this. The function f, it takes numbers in, like it'll take the number 2, it'll send it to the number 4, right? It'll take the number 3, send it to the number 9, right? That's what a function does. It takes numbers in and spits out a new number. That's what functions do. They take numbers to numbers. This is different. I'm taking a function as the input, right? The input is a function, and the output is a new function. So this thing that does it is not called a function. It's actually called a functional operator. It feeds on functions. You give it a function, it gives you a new function, as opposed to a function which takes in a number and spits out a number. You see the difference between the two? So what I'd like for us to do right now is I'd like for us to look at the graph of this, all right? I'm going to go to Desmos, I'm going to graph the original function, and then I'm going to graph the derivative together on one screen, and we're going to see if we can make a visual connection between the two. That's, so here's the first one. I'm going to do, bless you. No more though, please. 3x squared minus 5x. Okay, let me turn this one off. Okay, what we're looking at here is the original function 3x squared minus 5x, right? Seems reasonable, right? That's parabola. Okay, now here comes its derivative. What's cool about Desmos is that with Desmos, let me erase this. With Desmos, if you type in the functional notation, f with the parentheses around the x like that, then on the next line, all you have to do is put f prime of x, and it'll graph it for you. Like it'll do the derivative for you, which is cool. But I'm going to type in the function. I'm going to call it g of x, even though it's not. And it was 6x, what was it? 6x minus 5, right? 5, there we go. And I'm going to move this off screen, kind of widen this out. All right. So in blue, right? In blue here is the derivative, right? That's the derivative function. And in red, you have the original function, right? All right. So remember, the derivative tells you about the slope of the tangent line, right? Now, back in the first two derivative definitions, those formulas would give you the slope of the tangent line at A, right? A would be that point. Now we're saying that point A is no longer A, it's X. We're calling it X. So that new function in blue should be giving you the slope of the tangent line of the red curve, or the red graph, at any particular point. So let me go to one point right here that I think most of you will be able to see clearly. If I go to this point right around here, what would the slope of the tangent line be there? What do you think? If I draw a tangent line, what would the slope be? 0? Do you all agree that the tangent line, if we drew it there, would be flat? Yes? So right here, you're telling me that the derivative at that point, now I can't tell what that point is, but the derivative at that point, x, is 0. Agreed? Well, look at the blue curve, look at the blue function. What's the blue function doing at that same x value? It's what? It's crossing through the x-axis, which means the value of this function